After the scandalous incidents when the batteries of various electronic devices started exploding in the hands of users, experts all around the world claim that the future of electronics and technology is with solid-state batteries. The key difference between solid-state batteries and lithium-ion batteries that we are used to using is that the electrolyte is in solid form rather than liquid. Solid-state batteries have been developed for more than 40 years. However, the supporters of this implementation haven't yet pleased us with news of great success. Today, Elon Musk decided to give a second chance to lithium-ion batteries and developed a new type of battery cell called the battery cell 4680. Tesla has been involved in battery cells for a long time, but it never manufactured them itself until starting production of 4680 last year. If Tesla can start producing these new batteries, does this mean that solid-state batteries will be a thing of the past? Electric cars aren't a luxury, but a means of transportation. These words could become the motto of their greatest supporter and the flagship of the entire industry, Elon Musk. Over the past years, cars that don't need to be filled with gas have turned from a fantasy and slightly ridiculous concept to an element of status and a dream for many modern car enthusiasts. Now we can claim without a doubt that the future is in the hands of electric cars. But there are many technical nuances that must be improved before the world can fully switch from gasoline engines to electric ones. One of the most important nuances that requires improvement is the heart of the electric vehicle, its battery. In 2019, Tesla acquired two companies, Maxwell Technologies, which develops supercapacitors, and Hybrid Systems, which specializes in the production of high-performance batteries. Musk's secret project to establish mass production of new batteries with higher density and lower cost was called Roadrunner. Tesla's executives are confident that the new batteries will soon appear in electric vehicles as well as in energy storage systems. Tesla's team of scientists have indeed been able to create and demonstrate a working prototype. Elon Musk held the presentation of its new 4680 battery at Tesla's annual event, Tesla Battery Day. But on the other hand, he clearly demonstrated that the new elements are much cheaper than the existing ones and can store much more energy per unit volume. Tesla designers remained faithful to the finger-shaped format of lithium-ion batteries, but made the new battery 5 times larger. To this day, the main problem in the way of increasing the size of individual batteries has been that with the increasing power, their thermal load also increases. Simply put, these batteries are prone to overheating. Tesla assures that they have managed to solve this problem. The cylindrical element of the new format 4680, as in 46 mm in diameter and 80 mm in height, uses the manufacturer's patented non-contact pen contact design, which has lower internal resistance values. Instead of a contact plate, the current is applied through a wide contact around the entire edge of the electrode strip. Engineers laser etch the cathode foils in the cell to create a tiled helix, which reduced charge travel to 50 mm compared to 250 mm in current cells. This new element makes it possible to obtain a 14% decrease in the cost of a kilowatt-hour thanks to the change in the form factor of the cell, an 18% decrease in the cost per kilowatt-hour, resulting in a 10-fold reduction in production space, a 10-fold reduction in energy consumption, cost reduction per 1 kilowatt-hour by 12% due to improved cathode material, and a 7% decrease in battery cost per kilowatt-hour due to the new integrated vehicle design. Tesla has upgraded its cars with new front and rear castings that integrate with the battery. To achieve this, the company has developed a completely new alloy that allows the casting of large objects. Overall, the redesign of the cathode battery and vehicle frame resulted in an expected 56% improvement in Tesla machines. Compared to the elements of the 2170 format that are being installed on Tesla machines right now, the new 4680 form factor provides a 5-fold increase in energy intensity, a 6-fold increase in power, and will increase the range of Tesla vehicles by 16%. If Musk's calculations are correct, in 3 years he will be able to bring the promised low-cost $25,000 Tesla to the market. That's impressive. But what about the developers of solid-state batteries? The well-known benefits of solid-state batteries are their lighter weight, higher charging speed, and safety. At least that's what's written in the manufacturer's presentations. However, it is difficult to verify their statements in practice. While solid-state batteries have been used in pacemakers and wearable technology for many years, porting to a device as power-hungry as a car is still risky. By the end of 2022, production of 4680 batteries will increase to 100 gigawatt-hours per year. Mass production of new batteries will begin in 2022. They are primarily intended for future cars such as the Roadster and Cybertruck. In the meantime, 4 leading battery manufacturers of the world, including LG, Energy Solutions, and Samsung, have announced plans to create their own version of Tesla 4680 battery cells. Last October, Panasonic, which works closely with Tesla in the battery industry, announced that it will also begin mass production of the 4680 battery in Japan in 2022. According to company representatives, the new battery requires a higher production culture. The large cells are harder to cool and therefore more prone to overheating. For now, the company is ready to produce about 2.5 billion cells a year. It's obvious that manufacturers of solid-state batteries have nothing to counter such a large volume of production. Their only chance to stay in the market is to convince some of the industry's flagships to invest heavily in improving technology and launching a line of solid-state electric cars despite their cost. Do you think there will come a day when we have to decide to buy a car not based on gas and electricity, but based on lithium-ion or solid-state batteries?